In this example, we have log base 2 of x plus 2 plus log base 2 of 1 minus x equals 1. We're going to use the properties from 6.5 to rewrite this problem. So the first thing we're going to work with is that plus sign on the left-hand side between the two log values. They both have the same base, they're both log base 2, so we can actually use property number 1 and combine that left-hand side using multiplication. I'm going to go ahead and write P1 right here next to the problem, just as a reminder that that was the property that you guys were using to combine the arguments of that step with multiplication. Our next step is going to be to identify each of the pieces. We can identify our base, we can identify our exponent, and our argument piece, and we want to go ahead and put this in exponential form. So I've gone ahead and identified each of the pieces. 2 is our base, our exponent is 1, and the argument are those two pieces being multiplied together, the x plus 2 and the 1 minus x. When you go to write this in exponential form, if you want to go ahead and FOIL that argument out, go ahead and do so. Now, I went ahead and simplified. 2 to the first power is 2, and on this right-hand side, I'm going to go ahead and FOIL, and when I do that, I'm going to get a negative x squared minus 2x plus x plus 2. Now, you'll notice that you have an x squared piece here, so we have some type of quadratic equation, and so we want to make sure we get everything on one side, 0 on the other. Make this easier on yourself. Go ahead and put your x squared term where it's going to be positive. So in this case, I'm going to go ahead and move everything to that left-hand side. And when I do that, I'm going to get x squared plus x equals 0. This is something that's nice and easy to factor. Both terms have an x in common, so I'm going to go ahead and factor the x out. If I go ahead and continue this problem, I factored this into x times x plus 1 equals 0, and then I went ahead and set each of my factors equal to 0. So two answers here, x equals 0 and x equals negative 1. Now, remember, we're not done at this stage. We want to go back and check our domain pieces to make sure that both of those numbers work, or to check to see if we have to discard one of those values. So I'm going to go all the way back to my original equation up here, and I'm going to work with those argument pieces and make sure that both of them are set so that they're greater than 0. So when I'm checking these domains, I have two pieces here. My x plus 2, that came from right here, has to be greater than 0, and the other argument was this 1 minus x. That piece also has to be greater than 0. And I'm going to go ahead and solve each of those inequalities for x. So in this first one, all I have to do is subtract the 2 from both sides. And I'm going to end up with x is greater than negative 2. If I'm looking at the two solutions I had, my x value of 0 is definitely a number that's bigger than negative 2, and x equals negative 1 is also bigger than negative 2. So far I can keep both of those solutions. Let's check the other one. When I solved this inequality, I went ahead and subtracted 1 from both sides, and that gave me negative x is greater than negative 1. And since I'm solving this for x, I can divide both sides by the negative 1. Remember that when you divide by a negative sign, you're going to have to make sure you flip your inequality symbol. So right now, x has to be less than 1. If we come back and check the two solutions that we had, both of these numbers, the 0 and the negative 1, were values that were less than 1. So in this case, we can actually go ahead and keep both solutions.